Hello. With this video, I'd like to take you through the creation of a simple animated game with Dolphin Smalltalk. This actually comes as a response to an inquiry on the Dolphin Smalltalk newsgroup, where a chap wanted to make an air traffic control simulation game. And if we just take a look at his message, we'll be able to get an idea what we're trying to achieve. So what Mike says is, "Greetings. I'm trying to create a very simple air traffic control radar display simulation. Is it possible to create an object for the playground that is a combination of a regular polygon and a number of attached dynamic text objects? It doesn't necessarily have to be a playground view, I just started with that. Will just a standard shell view work? I want to animate 2D multiple squares in the view that each have 4 text attributes, the squares representing the planes. I also need to be able to dynamically add/remove the group boxes. I tried creating a shell view with a group box containing 4 text fields, but I haven't found out how to access/animate the group box. Is it possible? Is the created view accessible in the class browser, or if not, where?" Okay, well the first thing to point out really is that it's not a good idea to try animating Windows controls that have been created as part of a group. Windows controls were never meant to be moved around on the screen, and the effect, if you can achieve it at all, will actually be quite poor. Generally you'll get very a flashy animation. So the best thing to do really is to start from scratch. You could start from the playground view, which is one of the Dolphin tutorials, but really that doesn't give you that much of a leg up. So what I'm going to show you here is how to start basically from scratch in creating this sort of game. Okay, so now we're ready to get started with programming this simple air traffic control game for Dolphin. We're going to do this in the free community edition of Dolphin, just to show that it can be done there. Obviously, if you have the professional version, then there are a number of features in that which will make things a bit easier. But in any case, you can get quite a long way with the free version without too much pain. Let's start up Dolphin. And dismiss the splash screen. Now, we're going to build this game in the Dolphin user interface framework, which is called Model View Presenter, or MVP for short. The idea behind that is that a user interface is composed of a triad of cooperating classes. The model class is where the heart of the application resides, and the model objects tend not to know anything about the user interface. They just, in this particular case, there may be things like planes or the airspace or whatever, but they don't necessarily know what is what is presenting them on the screen. And the objects that do that are the view object, actually shows the contents of the model in a window on the screen, and the presenter objects are responsible for taking actions from the user, processing them and using them to make modifications to the model. So without further ado, let's get in and start designing some stuff. The first thing we want to do though is create a package to place all our classes. It's the first thing you should do when you create any sort of software of your own. So let's go into here, and we right click in the packages window, say new package, and we're going to give this a file name of ATC game. Okay, and we have a new package down here. Now if you right click on that, you can see we can set that as our default package, and this is the place where any classes that we create where we don't explicitly package them will go. Excuse me. Right, so having done that, let's launch our class, close this and launch our class browser and create some classes. Okay, so in the class browser we're going to create 3 sets of classes to start. One is going to be the model class, one is going to be the view class, and one is going to be the presenter class. Typically we'll put models under the model superclass, so let's go and search for that by typing in the find box. So here is a model, and now let's right click on that to create a new class. We're going to call this ATC model. Okay, and we're going to turn off the packaging option so that it goes into our default package. And so we have our ATC model class. It's been put into the ATC game package. Okay, now let's go and create ourselves a presenter to match that. Because this doesn't need to inherit from any other presenter that we have, we're going to descend this direct from the presenter superclass. But as you can see, there are a lot of different options underneath here if you find something that it's similar to. So once again, new class, ATC presenter. Turn off the packaging. Okay, and now let's go and create our view. So we'll find the view hierarchy. Now this is slightly different because what we want to do is we can inherit from in here a view that's actually going to be quite useful to us. Since we're going to be drawing animation on the screen, it's quite important in order to avoid flashy display to use a double buffering process where any changes are first written to a back buffer and then flipped instantaneously to the screen when all the composition is ready. Dolphin has such a view class, and it's called double buffer view. Excuse me. I'm just going to expand that so we can see we've got a couple of examples beneath that. One is this bouncing ball view, one is a sliding ball demo. And if I just show you the bouncing ball view, you'll get the idea that we can do smooth animation with this class. So if I right click on here and I'll do that. So if I go to the samples and I choose bouncing balls, this is an example of the animation feature of that double buffer view. Okay, so going back here, let's create our ATC view class as a subclass of double buffered view. Okay, we've done that. Now, first thing we want to do is we want to get this triad all hooked up so that we can just get something on the screen and start working. So let's do the bare minimum we need to do that. The first thing we need to do is we need to tell the ATC view what its default model is as a class method. So we go to the class side, create a new method, default model, and it's going to be an ATC model. Sorry. New. Okay, so that's going to be the default model we can apply to any one of these views. Similarly with the presenter, that can also make use of this. So what we'll do is we'll drag this this method to our ATC presenter. So we'll find our ATC presenter here, and we can drag our method and copy it into the ATC presenter class. Okay, that'll help there. The next thing we want to do is we want to link up the view object with a presenter. Now the way that Dolphin does this is we create an instance of the view and we save it down as part of the presenter class as its default view. So the easiest way to create a default instance of a view is to right click on it, go to the Views submenu and say New. We'll give it a resource name of default view. Okay, and we launch the view composer. We can make some changes to this, but for the time being, that's all we want. This ATV view is a double buffer view. It's got a number of parameters down here which we could set if we wanted to, like the background colour. But for the time being, let's just save this down as the default view of our presenter. So we'll save this down, and it's asking us which class to attach it to. By default, it's the ATV view class, but we want to attach this to our presenter, which is ATC presenter, and I'll save that down. With that done, we can dismiss the view composer. Now let's go and look at the ATC presenter class and see what's happened. Okay, so we don't see very much on the instance side, but on the class side of our ATC presenter, we see we have the default model method that we created and copied over from our ATC view class. This just tells us what the model will be by default when an ATC presenter is created. And we also have this resource default view method, which is machine generated by the view composer, and will rebuild the view exactly the same way that we specified in the view composer before saving it down. Okay, before we actually go and instantiate one of these MVP triads, we need to add a few more methods on the instance side of the presenter. Excuse me. We're going to need to have an update process that causes the game to update periodically and also re-display after it has been updated. So let's create an update process and assign it to an instance variable inside the ATC presenter. So let's call that instance variable update process. Okay, and I'm going to create an instance side method also called start update process. And what I'm going to do here is assign to that variable what we want this update process to do is to, first of all, we want to update the game. This is a method we're going to define in a minute. Next, we want to cause the view to repaint after the game is updated. And then we better pause for a bit, really, otherwise we'll be hogging the CPU. So let's ask our processor to sleep for, say, 15 milliseconds. I mean, we could choose any frame rate you like, really. But providing the game isn't complex enough to get overloaded by the refresh rate. And then that's going to be repeated ad infinitum. So that's our basic update process, and we now need to fork that. We're going to fork this at user background priority. So it's running in the background. Okay, and let's just compile that and see how it looks. Okay, so we've compiled that, and we've been warned that we don't yet have an update game method. Well, we can go and create that now. And for the time being, let's just make it do nothing. Similarly, we're going to need a stop update process. Now, we only want to do this if the process has already been started, so let's put a guard clause in, just to check to see if the update process instance variable is non-nil. So if it is nil, we'll just early out and return from this method. We don't need to stop anything. If it's not, we will terminate the process and we will assign that variable to nil so we can know that it's been done. Okay, and just one thing just occurs to me is really to avoid starting multiple processes, we should ensure that any existing process is stopped in here first. So let's call stop update process in here first. Let's compile that. And we should basically have enough now to get us going. I'm going to save this down just in case anything goes wrong. It's always a good idea to save your image before you're doing anything tricky. So let's create a workspace now, and inside this workspace we're going to instantiate one of our ATC presenters. by sending it a show message. So I'm going to assign that to a workspace variable. Okay, and I'm going to ask it to show itself. And when we do this, basically the Dolphin framework will create as a default model, which will be our ATC model, attach it to one of these presenters and attach a view to it, and then show it in a window on the screen. So let's see if that happens. And there we go, we've got our window on the screen. And actually one thing occurs to me is we haven't actually told our processes to start when the window opens. So I need to just go back and cause that to happen. So I'll close this window. What we need to do is we need to override onViewOpened here. We need to supersend that. If you don't supersend it, all sorts of strange things will start happening. And we need to start our update process. And similarly, in onViewClosed, we need to override that and do the opposite, which is to stop the process. Now, in here, we need to send the super onViewClose at the end of this method to preserve the correct order of destruction of the window. Here I want to do stop the update process. Okay, that's good. Now these two we can label as private methods. Right click and choose private. Right click and choose private. And also update game isn't intended to be called from outside, so let's also make that private too. The start and stop update processes can be left there as public, since we may want to be able to manipulate the background processing separately. Okay, so now if we go back to our workspace window, let's just clear that old workspace that I have from a previous session. Let's instantiate this ATC presenter again. Okay, and let's resize that. Okay, now we're not seeing very much happening at the moment because we haven't actually told it what's in our model or anything at all, really. So the first thing to do, let's get the view to ask the model to display itself in this window. Now to do this, I'm going to use a quite interesting feature of Dolphin, which you may not have seen before, and in fact, in general, you can do this with most Smalltalks. We're going to start doing a bit of coding in the debugger. So basically, we can make a change and to call an as yet undefined method, and when that gets called, the debugger will spot this and pop up, and we can then implement the code directly there. This can be a very fast way of fleshing out an application. So let's go to our view. Okay, so what we want to do in here is we want to create a new method called render, which overrides the one in our superclass, and we will ask this to render or draw the contents of our model onto the associated window. So let's get our model and ask it to draw itself on our canvas. Now in Dolphin, a canvas is simply a Windows device context. So let's ask it to draw itself on a canvas. And we need to do a little bit of housekeeping, tidying up by calling our super render method as well. Now the point here is that we haven't yet defined draw on in ATC model. So let's compile this and see something interesting happen. So I accept the code here, and we get a walk back, as we might expect in fact. ATC model does not understand draw on. Well, we haven't written a draw on method for our ATC model yet. So let's go and do that now. And we can do that, as I say, inside the debugger. So if we click debug, debugger pops up, and we can bring down the debug menu and choose implement in ATC model. And this will write as a pro forma method in our ATC model class, which we can now complete and compile and then go on our merry way. So just to check that this is working, let's actually just write a little bit of text out onto our window. If I move our window just over a little bit, our debugger over a bit, so we can see that window. So a canvas, let's use the text at method, which takes a string. And we can draw that at 50-50. Now, if I compile this and then let the debugger run, okay, there we go. We've actually got our little bit of text has popped up. Now, one thing you might remember from when we were editing the view with the View Composer is that we actually specified a background colour of white in this window, but we're not currently seeing that, we're seeing black. So let's go and see what we can do about that. Let's go back to the render method in ATC View, and before we actually ask the model to render itself on the canvas, let's ask it to draw the background colour on that canvas first. Now, what I'm going to do is I'm going to extract this self-canvas part out into an instance variable. If you had Dolphin Professional, you'd be able to do this with a simple refactoring operation. Okay, and before we actually use that, before we actually do the drawing, let's set the background colour of the canvas to be the same as the background colour of our view. Okay, and we can then ask the canvas to erase itself. Now, what I want you to remember here is this, in the background here, this presenter, the game is still running basically, and as soon as we compile this code, it will go into action in the game. So let me accept that piece of code. Okay, and we've now got our background colour of white. Fantastic. Just compile that with a bit of reformatting as well. So reformat. Okay, now the next thing to do, I think, is to flesh out exactly what the model should be and what it should actually be drawing. Well, to my mind, I think this model actually should represent an air traffic controlled airspace, which will contain a number of different plane objects. So basically, I think what we need is an ordered collection of planes inside this inside our model, and we're going to draw each one of them one by one. So the first thing to do, perhaps, is to go and create ourselves an ATC plane object. We'll descend that from Object. And we'll let the default packaging take over. So we have an ATC plane, and let's go into our model, and what we want is to have a collection of planes inside this model, which we can add to, and we can cause them to move around. So we'll create an instance variable called planes, and when the model is created, I think what we want to do is initialize that planes instance variable to be an empty ordered collection. So let's do that. I'll create a class side method. New. Oh, in actual fact, we don't need to do this because if we just go back up here, you'll see that models actually do always get initialized. So we don't need to override that and resend initialize. So what we'll do is in our ATC model, we'll create an initializing method, which we'll call super initialize, and also it's going to initialize our planes instance variable to order collection new. Excuse me. Now, normally we would have to let's categorise that method first. Let's put that into category initializing, and let's make it private because it's not called from outside. Similarly, drawn isn't called from outside. Now, normally we would have to restart this and to get this initialize method to be called, because we've gone past the initialization stage. But one thing we can do here is we can use the visual object finder to go and bring up an inspector on this object here, and inside here we can get at our model, looking at the instance variable side, and we can see that we have a planes instance variable of nil. And let's actually just go inside and assign a blank ordered collection to that. And if I accept that, you see we now have an ordered collection in there. So that's all set up just as it would be as if we restarted it. We haven't actually had to restart the game at all. Okay, so now we're being drawn by our viewer whenever we need to draw the objects in ourselves. So instead of having our drawing hello world, which is obviously not part of the way we want the game to act, let's actually make it do something more sensible, which would be to actually go through, enumerate through all of the planes and ask them to draw themselves. So go through each plane in turn and forward our draw message to that. Now once again, when we compile this, we actually have some more methods which have not yet been defined. In particular, we have this accessor for planes, and eventually when we come to it, we're going to find out that we haven't actually defined a draw-on method for each of our ATC planes. So let's debug through this and do some more coding in the debugger. Okay, first of all, let's implement planes method in ATC model. Now, because there's a planes instance variable in this model class, the debugger will actually go and fully implement the method for us, so we don't need to do the code at all. And now we can just let that run again. Okay, let's go and take a look at our ATC plane class. So I was expecting it to have a draw. Oh, we haven't got any planes in there, of course. Sorry, my fault. We haven't added any planes into this into our game space yet. So let's do that now. So let's go back to our workspace and let's add a plane in there. Actually, the first thing we might want to do is we might want to define a bit more detail about how the planes work. So I'll go to ATC plane and let's add a bit more information in there. Okay, in the class definition for ATC plane, what should we have? Well, I think we're going to need something like a flight ID, so we can identify the planes. We're going to need a position, and also probably a velocity vector as well. I think what we'll do is we'll make the positions and the velocities, let's make them 3D vectors. So even though the game's a 2D game, we can actually represent the height above ground and the changing height. So let's do that. So we'll have a flight ID, and we'll have a position and a velocity vector. Let's compile those in. Now, we want to set probably all of these things initially, as well as allow both the velocity and the position to be overridden. So let's create some automatic accessor methods for these. We'll create accessors for all three. Okay, but I'm not going to allow the flight ID to be set after the initialization, so I'm going to delete that method. And I think we can keep the others. But on the class side, I think what we want is a constructor method which takes the flight ID, the position, the initial position, and the initial velocity. So let's Let's write this method. Position. I'm going to give it a 0.3D. And the velocity can be a 0.3D velocity. My typing. Okay, and we're going to answer super new, and we're then going to set the flight ID string. Oops. Of course, I deleted that access method. I'll put that back in again in a minute. We're going to set the position. And we're going to set a velocity. Okay, and we need to answer the newly created object. Okay, so yes, we haven't yet got the flight ID string in there, but in fact we can code that in the debugger when the time comes. So we can create one of these objects now, and then we can start adding those to the game and fleshing out some more methods. Okay, so let's get ourselves a plane. And we'll use the flight ID position this method. Let's stretch that out so we can see what's going on. Let's give it a string of BA188, British Airways flight. We'll position this at, well, let's position this at 50 at 50, which is the horizontal plane, and we'll give it a height of 3,500. We'll see why in a minute, and we'll give it a velocity of 0. Let's make it 50 at 0 at 0. So we're giving it an x velocity. Okay, if we evaluate that, we see that ATC plane does not understand flight ID. That's because I deleted that accessor erroneously. So let's just go into the debugger and ask it to implement that for us, and then let it run with an F5. Okay, so we've got an ATC plane here. What it might be quite nice to do is to actually define a method in plane, which will give us some more details about what plane it is when we're debugging. So let's create on the instance side of ATC plane. Let's be private as well. We can make these accessors here public, just so these ones, the flight ID can remain private. Okay. So sorry, on the instance side, let's create a print on method, which is the way of printing onto a stream the information about the object that the developer wants to see. So the standard print on mechanism just reports an ATC presenter. If we just do that again, oops, so I didn't define that method. I'll go back here. So what we want to do is we want to call the super method, super print on, but then we want to append to it possibly the flight ID information in brackets. So we can next put a open brackets followed by next putting all our flight ID and followed by closing brackets. do that. And now if we go back and recreate our plane here, we should see we get an ATC plane and we can identify it as BA188. You could add in also the more information into that string as well if you wanted, like the position and the velocity, but let's not do that here. Okay, so let's add that plane to our game. So we'll say we want to add it to the model part of the game, so we're going to create an add plane method which takes a plane as a parameter. Once again, we can do the coding in the debugger, so let's evaluate that. ATC model does not understand add plane, so let's debug it and implement it. And so what we want to do is, in here we want planes add, oops, excuse me, add an ATC plane. Now when I compile this, I expect something else to happen when we let it run. Okay, now we get the condition I was expecting before. We get an ATC plane does not understand draw-on. Because our model is transmitting draw-on messages to any of its contents, now we've added one of the contents, we've now got to define the draw-on method in ATC plane. So let's go and debug that. Once again, I'll move this out of the way just so we can see, we've got the game space here so we can just see what's going on when we actually compile this method. So once again, let's implement this draw-on method in ATC plane. And now what are we going to need to do here? Well, I think what we want to do is we want to draw a box representing the plane and then some salient information around it. So let's first start off with the box. So we'll ask the canvas to fill a rectangle with a particular colour, and that rectangle we'll write a method for. We'll call it self-box. And we'll provide it with a colour. Perhaps we actually should include the colours inside the as an instance variable part of the plane. But first of all, we'll just write a method to abstract that. So we'll get our plane's colour. Let's compile that and let it run. Okay, ATC plane does not understand box, that's fair enough. I'm going to debug that now. And let's implement that box method in ATC plane. So we have a position, let's draw a box around that position. So our box will be self position, it'll be a rectangle, centered on our position. And it's going to have a particular extent, the size of the box. Once again, we can code that as a method inside our object, so we can parameterize it more easily. Now, one of the things here is that I'm expecting this position to change to actually contain floating point numbers as the position changes slowly. So we need to round this position down to integers, and also because it currently has, as you can see, has a 0.3d in it. What we need to do is we also need to cast that down to or convert that to a two-dimensional point. So if I put as 0.3d as point in here, if we just inspected that, we'll see that that will give us a 2D point. You see, that will just takes the x and the y coordinates, so that's what we want. And also we want to round the result, because the rectangle center extent method only takes integer value points. So let's compile that. Okay, and let's let it run. Okay, we haven't yet defined our box extent method, so let's do that. Let's implement that in here, and here we want to return a point, which is going to be the size of the box to draw. Let's make it 30 at 30, for example, for the time being. Compile it and run it. ATC plane does not understand colour. This is another method we put in there to parameterize the plane. So we once again will implement that. And let's just make it green for the time being. Let's run that. Okay, there we go. And we've now got our green box representing our plane. In fact, I don't particularly like that green colour, so I think what I might do is I might just change that to dark green. That's better. Okay, the other things we want to do inside our draw-on method are to implement we want to print out some text strings at the corners of the boxes to identify information about the plane. So the first thing, let's put the flight ID at the bottom right-hand corner. So we'll put the text of the flight ID and we'll put it at box bottom, excuse me, right. There we go. If I compile that, we'll see what happens. Okay, there we go. We've got our BA188 there. Now I think it might be quite nice if we can change the font of that. So at the top here, we'll set the font of the canvas to be equal to, we'll give it a font of Arial and a point size of, say, 8. There we go. And now maybe on the top top left-hand corner, let's put the flight level of the plane, the height of the plane. The flight level typically is the height in feet divided by 100. I haven't actually considered what the scaling here is in the game, but so at the moment I'm going to assume that the y coordinate is in feet, and that the z coordinate is in feet, and that the x and y coordinates are in some other scale, which can be determined later. So let's work out how to place our flight level at the top corner. So once again, we want a text at method. We want to get the flight ID, the flight level, and we want to put that at the box top left corner. Okay, let's compile that. Yes, as we expect, we haven't actually implemented the flight level yet. So we need to do that. And the flight level is going to be the position, z coordinate, integer divided by 100. Okay, so I'll now compile that and let it run. Okay, now we've got an error here. Let's go and debug that. It's an unexpected error. Okay. Okay, we've actually passed the flight level across as an integer, not a string. So we'll go down to this method here, and we can basically ask this flight level to represent itself as a string. Okay, and if we recompile this now, we're several frames down on the stack, but if we recompile this now, we'll actually be able to restart that method and let it run. Okay, small integer not understand. Let's not use as string. Let's use display string. Okay, and let that run. There we go. And now we've got that up in the top left-hand corner. It's not quite what we want because we want it to be outside of the box. So let's assign that string to an instance variable and call that FL text. Okay, and then let's use the canvas to measure the size of that text so we can work out where to put it. Okay, so we're going to have the text extent, and we'll compute that like this. And give it the FL text string. And now, once that has been computed, we can subtract that from the top left-hand corner of the box. Remember that Windows coordinates are positive, down, and to the right. So we can actually subtract that text extent, and it should position the text where we want. If we compile this now, yeah, that's fantastic. You see that our flight level's gone up to the top right-hand corner, top left-hand corner correctly. And in fact, just to make it look a little bit better, let's prepend that with the characters FL, and that looks a bit better altogether. Now, another thing that might be quite nice to do might be to display a velocity vector that indicates which direction the plane is moving in. So let's also draw that in here. So let's create a vector, and what we want is we want that line to be a fixed length and not particularly relevant to the actual speed of the plane, because that will be indicated by the actual movement on the screen. So what we'll do is this vector can become equal to the velocity as points, so we get the 2D velocity, and we can divide it by the magnitude of that value. Well, in fact, let's actually extract that out into a temporary. So we'll have velocity 2D okay, so now we can have we're using an integer divide here because we want this vector to be suitable for drawing on the screen. Now that's going to give us a unity vector, so which represents the. So we need to multiply by the length that we want. So we're going to multiply this vector here by the length of the line, which let's make it 100. Okay, and let's now draw this vector on the screen. So we're going to ask the canvas to move its cursor to the center of the box. Okay, and then we're going to ask it to draw a line, the center of the box offset by that vector. Okay, that should do it. Let's compile it and see what happens. Oh my word, it actually works. So we've got our line in there. Maybe that's a little bit too long, so should we shorten that line down to about 70? So, in fact, really, we should parameterize that. So let's make that vector length, and we'll be asked to create that method. and let's make that 70. Okay, that's great. And I think that's really basically what we need to actually be able to get going. So the next thing we might want to do is to animate what we've got, but for the time being I'm going to save the image and I'm going to go and get a coffee.